Hi, welcome to the Olympiad geometry. Let's continue our study of 9-point circle. Here is a problem. In triangle ABC, AD is altitude of edge BC, MN are midpoints of CA, AB, respectively. Line L is through A. B prime, C prime are the projection from BC to L. B prime N intersects C prime M on point P. Show that B prime C prime D P are cyclic, and its center O and P are on 9-point circle of triangle ABC. So here the figure is not good enough that it looks like P is on the BC, but actually P is not on the BC. So just illustrate that a little bit, and let's consider about how to prove that B prime C prime DP to be a cyclic quadrilateral. The very basic thing is that we can just connect the B prime D, connect the C prime D, right? If we can prove that B prime angle B prime PC prime equals to angle B prime DC prime, then we know that B prime C prime DP are cyclic, right? So start from here, B prime DC, and look at B prime PC prime, right? So B prime DC prime, we can rewritten as angle B prime DC prime equals to angle B prime DA plus angle C prime DA, right? It's straightforward. A equals to B prime DA plus C prime DA. And we know that AD is perpendicular with BC, and AC prime is perpendicular with CC prime. So ADCC prime is a cyclic quadrilateral, which means that angle ADC prime or C prime DA equals to angle C prime CA, right? Similarly here, because this is 90 degree, this is 90 degree, so ADBB prime is a cyclic quadrilateral, and angle B prime DA equals to angle B prime BA, right? So we can rewritten this as angle B prime BA plus angle C prime CA, right? And B prime BA equals to 90 degree minus B prime AB, right? Because this is 90 degree, so equals to 90 degree minus angle B prime AB. And C prime CA equals to 90 degree minus C prime AC, angle C prime AC, right? So it equals to 180 degree minus angle B prime AB minus angle C prime AC. And because N is the midpoint of right triangle ABB prime, and M is a midpoint of the AC in the right triangle AC prime C, right? That means AN equals to B prime N equals to BN, right? So this triangle equals to this triangle. I mean this angle equals to this angle, right? Then we can return this B prime A B into A B prime N, right? So equals to 180 degree minus angle A B prime N minus angle. Similarly, C prime A C, this one here. I just fill it here, right? Because AM equals to MC prime equals to MC, so angle C prime AC equals to angle AC prime M. right? AC prime M. Now look at the triangle B prime PC prime. 180 degree minus angle AB prime N minus angle AC prime M, that equals to angle B prime PC prime, right? So we directly get that B prime DC prime equals to angle B prime PC prime. So we know that B prime C prime DP are cyclic. Now we want to prove that the center O of this cyclic quadrilateral and point P are on the 9-point circle of the triangle ABC. We already know that 3-point can define a circle, and in this case, that 3-point can be 3-point can be found as the midpoint of AB, midpoint of AC, and the foot of the altitude AD, right? So N, M, D. We just need to prove that N, M, D, P are cyclic. So we connect ND, we connect MD. Right? If we want to prove that N, M, D, P are cyclic, we just need to prove angle NPM, which is actually the angle B prime PC prime, right? We just want to prove that angle NPM equals to angle NDM. We connect NM. Right, we want to prove this one. So similarly, we just write that angle NDM equals to angle NDA plus angle MDA. Right? Angle NDA plus angle MDA. And because N is the midpoint of AB and ABD is a right triangle, so that ND equals to NA, which means angle NDA equals to angle NAD, right? And angle MDA equals to angle MAD, right? And this equals to angle BAC equals to 180 degree minus angle B prime AB minus angle C prime AC, right? So look at here, the angle NDM equals to this one, and the angle B prime PC prime, which is angle NPM, equals to this one, right? Which means angle NDM equals to angle B prime PC prime. So we know that NMDP are cyclic. Now we just need to prove the center O of the cyclic quadrilateral B prime C prime DP is also on the 9-point circle. Right? We just find circle. We just find the center O of the quadrilateral B prime C prime DP here. And if we connect P, OP, and OD, it's obvious that because O is the center of the quadrilateral B prime C prime DP, so angle POD equals to twice of angle PB prime D. This is always valid, right? Angle POD equals to twice of angle B prime D, right? And because see here, because B prime A D B is a cyclic quadrilateral, and angle B prime A is 90 degree, angle B D A is 90 degree. That means the midpoint of AB is a diameter, right? The midpoint AB, the N is the center of this quadrilateral, right? Which means NB prime equals to ND, right? NB prime equals to ND. That makes the angle PND to be, so because NB prime equals to ND, that means angle NB prime D equals to angle ND B prime, right? So angle PND is the summation of these two angles. That's twice of the angle PB prime D, which means angle POD equals to angle PND, right? We just proved that P is on the 9-point circle, that PNDM are cyclic, right? And we now know that angle PND equals to angle POD. That means PNDO are cyclic as well. And PND already can define the 9-point circle, which means that the circle of the circumcircle of the PNOD is also the same circle of PDMN, right? That's a 9-point circle. So O is also on the 9-point circle. Okay. This problem is not a difficult one. It just requires it just requires you to do some figure out that how to use the midpoint N and M and find the relation of the angles to figure out that find the cyclic quadrilaterals and use ways that to prove PDMN are cyclic, right? That's the core of this problem. Okay, I hope you like this video. See you in next one. Thank you.